Good morning, everyone, and welcome to another session of the webinar with Big Switch Networks. My name is Sunit Chauhan, Head of Product Marketing here at Big Switch, and I'll be your host for today's session. The topic for today's discussion is the unified P+V edition of Big Cloud Fabric, the BCF Fabric solution that is specifically designed for OpenStack pods. And to discuss the product and give us a demo of some of the latest functionality, I'm joined here today in the room by JP Shukla, Director of Product Management for BCF, and Ganpati Bhatt, TME for the same product. Welcome, guys.
Thank you, Sunit. Thank you, Sunit.
Thank you for taking the time. Now, as we prepare for the OpenStack Summit in Tokyo, we figured this is a good opportune moment to actually talk about the P+V functionality, which is the physical plus virtual Fabric functionality managed from a single SDN controller, and how that integrates with OpenStack. In fact, we will continue on the same theme in our next webinar in a couple of weeks when we have the team from Red Hat join us for a discussion of the RHOS P7 integration and how that is supported with BCF. But that again is for the future. Today we focus on the overview and the latest features and functionality of BCF for OpenStack clouds. This is the functionality that we made generally available with our 3.0 release. So let's get started. As Shannon mentioned earlier, just a couple of quick housekeeping notes to make here. As we go through the presentation, I encourage you to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or a recording, I highly recommend that you go to bigswitch.com/webinars and submit a question using the link provided there. Now, many of our webinars are built upon topics that we've covered in the past, which is the case today as well. So if you're interested in checking out some of those sessions, more details about a particular product or feature, you can access all of those again at bigswitch.com/webinars, and that's where all of our past recordings are available. And finally, if you want to try out the products, Big Cloud Fabric or Big Monitoring Fabric, you can always do that for free at labs.bigswitch.com. In fact, we actually have a couple of modules there that we launched, I'd say, a few months back, one specifically designed for P+V functionality, and another one that showcases the OpenStack functionality with the P+V Fabric. So with that, let's get started. Before I hand it over to JP and he goes into the details of OpenStack integration for the Big Cloud Fabric product, let me spend a few minutes talking briefly about the different deployment options that we have for the Big Cloud Fabric solution. Now, we've gone over the details as far as the architecture of Big Cloud Fabric is concerned in multiple webinars and videos in the past, so I will not repeat that in a whole lot of detail. But for those of our attendees joining us for the first time, BCF or Big Cloud Fabric is a leaf-spine cross fabric solution, and it is available in two different editions, two specific editions. The first one is the P-Fabric edition, which is a leaf-spine physical cross fabric controlled by the Big Cloud Fabric SDN controller. So in this case, the SDN controller manages, provisions, deploys pretty much all the troubleshooting, everything happens, but the controller is controlling the physical fabric, which is your top-of-rack physical switches and your spine switches. And with our 3.0 release, we announced the second edition of the product, which is the P+V Fabric. And in this case, it is a leaf, spine, and virtual switch fabric controlled by the Big Cloud Fabric SDN controller. And what JP is going to talk about today is how that SDN controller is seamlessly integrated with the OpenStack controller, and that makes all of your OpenStack workflows and scaling issues as far as Neutron is concerned go away. And that's sort of the topic for discussion today. Now, the easiest way to understand what Big Cloud Fabric is, think of it as the physical networking infrastructure in your data center. The key difference here is if you think of a large chassis-based switching infrastructure, you take it and logically chop it into pieces and rebuild the same functionality, but using a leaf-spine cross design and using open networking switch hardware. So same functionality, same features, better in terms of managing it, simply because what you can do, the benefit that you get here is not only the economical benefits that you get from open SDN fabrics, but more importantly, it enables you to do the kind of automation that is simply not possible with box-by-box networking. So that's how I think of Big Cloud Fabric when I explain it to people who are looking at it for the first time. Now, in terms of the deployment options, as you see on the screen, there are three different deployment options. that we've seen our customers use it in. The first one, let's start on the right-hand side, the third option on the screen. Consider it the plain vanilla flavor of the physical networking fabric for your data center. In this particular case, it really doesn't matter what workload you're planning to run. If you have a legacy networking solution in your, if you have a large chassis-based solution or a three-tier architecture in your data center, you can replace any of those solutions, legacy solutions, with a modern SDN solution, and that's the data center fabric solution, or the third deployment option. The second option from the right, the one in the middle, is the deployment solution, which builds upon the notion of this P-Fabric solution, but it's an SDN underlay solution that very tightly integrates with VMware vSphere. So if you have VMware workloads in your data center, and whether you're using the traditional vCenter networking or looking at NSX overlay, this is the deployment mode, which is, think of it as the best SDN underlay for your NSX deployment. And again, in this case, the key benefit here is we have completely integrated the vCenter workflow with the VCF controller workflow, and that provides the automation and visibility as well as troubleshooting. And finally, the topic of discussion today, which is the third deployment option, and the first one on your screen here, which is the OpenStack deployment. In this case, what we've done is we've extended the fabric, as I said, to the virtual switches as well. So the controller, the SDN controller, or the Big Cloud Fabric controller, now manages your spine layer, the physical switches at the spine layer, the physical switches at the top of rack layer, as well as the virtual switches, the open virtual switch running as a part of your KVM hypervisor. Note that this is a unified P+V. There is no notion of an underlay or an overlay here. The controller actually manages the physical and virtual assets as a single seamless fabric. So with that introduction, let me hand it over to JP, and he's going to go into the, a little bit deeper into the features and functionality and how VCF integrates with the OpenStack stack.
Hello everyone. Big Cloud Fabric is industry's first P+V SDN fabric on open networking hardware. And as Sunit mentioned, Big Cloud Fabric controller manages both physical and virtual switch. Physical switch run lightweight switch-lite operating system. Key responsibility of this switch-lite operating system is to boot up physical switch and program switch forwarding table. On hypervisor, we run switch-lite virtual, also known as switch-lite VX. This switch-lite virtual is a user space software agent on KVM-based Open vSwitch. Similar to P-Fabric solution, P+V Fabric has multiple capabilities, providing operational simplicity to end user. Application agility decouples physical and logical network, making it easier for customer to deploy application independent of workload's physical location. Zero-touch fabric enables complete control and management of physical switches within Big Cloud Fabric without manually interacting with the switches. It tremendously simplifies day-to-day network operations. Big Cloud Fabric controller coordinates rapid fabric upgrade. Last but not the least, fabric analytics and fabric programmability is supported. Well, we will not go in detail of any of these features. Today's focus is on additional benefit that P+V Fabric brings on top of P-Fabric. OpenStack is a primary use case for Big Cloud Fabric P+V solution. P+V Fabric solution supports both OpenStack Juno and Kilo release. Also, it supports key OpenStack distro such as Red Hat, Mirantis, and Canonical, providing choice to customers for their deployment. We have developed Big Cloud Fabric Neutron plugin, which is a single programmatic interface between OpenStack and Big Cloud Fabric controller. Big Cloud Fabric Neutron plugin provides full Neutron integration for Layer 2 and Layer 3 networking. Additionally, some of the protocols such as ICMP, ARP, LACP, etc. are offloaded from controller to switch-lite virtual. These enhancements bring higher resiliency to OpenStack solution when deployed over Big Cloud Fabric. Leveraging both physical and virtual switches, Big Cloud Fabric controller implements distributed routing and forwarding. Also, it supports distributed NAT for floating IP. Hence, OpenStack on P+V Fabric solution can scale better. In one of the test scenarios, we have successfully tested up to 300 OpenStack compute node in a single OpenStack deployment. P+V Fabric also supports LBAS and FBAS layer 4 to 7 service insertion. Big Cloud Fabric controller is a single pane of glass for physical and virtual switches. This makes troubleshooting fairly simple across physical and virtual boundary. It provides complete visibility of interface statistics across physical and virtual switches. We have extended Big Cloud Fabric test path feature into virtual switch. Hence, we can trace end-to-end VM to VM paths and policies applied on these paths. Additionally, leveraging BSN plugin, we bring in security group visibility in the controller, which further helps troubleshooting. Let's look into detail of some of these features and functionalities. On this slide, I have OpenStack reference architecture on the left hand and Big Cloud Fabric P+V architecture on the right hand. Boxes with light green color indicate OpenStack components. Boxes with blue color indicates components that are replaced by Big Cloud Fabric P+V solution. Starting from top, ML2 driver and L3 plugin are replaced with BSN ML2 driver and BSN L3 plugin. These convert layer 2 and layer 3 OpenStack networking information and pass it to BCF controller. At bottom, we have BSN vSwitch agent communicating with SwitchLite virtual running in user space of Open vSwitch. Neutron L3 agent functionality is offloaded to Big Cloud Fabric controller and SwitchLite running on physical and virtual switches. Let's take even closer look at SwitchLite virtual. On left hand, I'm showing Open vSwitch components. It has user space and kernel space. User space gets flow information from OpenFlow controller. It manages respective states and tables. Flow-based information is programmed in kernel space where actual packet forwarding takes place. Comparing it with right-hand side, we have shown SwitchLite virtual component. We leverage Open vSwitch kernel space indicated in same yellow color and modify only user space indicated by blue color. In user space, we run SwitchLite virtual that has capability to talk to Big Cloud Fabric controller and has Big Cloud Fabric forwarding pipeline. Also, user space includes offloaded protocols. This brings resiliency, scale, and simplified troubleshooting. Let's take an example to understand this better. First example I have is OpenStack east-west traffic. On left hand, I'm showing a typical OpenStack Neutron ML2 based installation. Here, physical fabric provides layer 2 functionality only. Layer 3 is implemented in host where OpenStack L3 agent reside. I have two tenants, blue and orange. Blue tenant has two segments, dark blue and light blue. Blue tenant router is on host 4. Similarly, orange tenant has two segments, dark orange and light orange. Orange tenant router is on host 3. Note that this is the best case scenario where both tenants L3 functionality is on different host. Worst case scenario would be where both tenant L3 functionality is on same host. Say VMweb wants to talk to VMDB across L3 boundary in blue tenant. Traffic will go from VMweb to blue L3 router on host 4. From there, it will go to VMDB. Similarly, if VM1 wants to talk to VM2 across L3 boundary in orange tenant, traffic will go from VM1 to orange L3 router on host 3. From there, it will go to VM2. If we look at these traffic flows, we can see that there are three problems. First, Fabric sees this traffic twice. Second, if you look at the host 3 and host 4 NIC, this data traffic competes with OpenStack control traffic. As we know, OpenStack is fairly sensitive to some of the control plane traffic such as RabbitMQ. With increase in data traffic, OpenStack can become unstable. Third, this example was with 2 tenants having L3 router on 2 different hosts. Now imagine you have 1,000 odd tenants. Host 3 and host 4 will cater to more than one tenant. In this case, host resources such as compute, memory, etc. will impact overall performance. Let's see how we solve this in BigCloud Fabric P+V solution. This is very similar OpenStack deployment with 2 tenants and 2 segments each. The key difference here is we have BigCloud Fabric deployment with BSN Neutron plugin, which offloads both layer 2 and layer 3 in the fabric. Since BigCloud Fabric controller manages both physical and virtual switches, you can see that Fabric extends all the way in the host. This Fabric handles layer 3 routing for blue and orange tenants. In this case, when web VM wants to talk to VMDB, traffic is sent to SwitchLite Virtual on host. Based on lookup, it's sent to Tor switch, which then forwards directly to destination Tor switch, end-to-end VM. Similarly, traffic is forwarded for VM1 to VM2 communication. As you can see, Fabric does not see the same traffic twice, no hairpinning to specific host, and hence no OpenStack control plane contention. Hence, OpenStack deployed on BigCloud Fabric P+V solution scales better. Let's look at second example. This is OpenStack north-south traffic. This is same deployment as previous example. Here, if VMweb wants to talk to outside world, traffic from VMweb goes to blue L3 router on host 4. L3 router will perform NAT floating IP translation and will send packet out. Similarly, for VM1 external communication, orange L3 router on host 3 will perform NAT floating IP translation. As we can see, we have same contention as previous example. Let's see how we solve this in BigCloud Fabric. In BigCloud Fabric, SwitchLite Virtual has floating IP table. When VMweb in blue tenant wants to talk to outside world, it sends traffic to SwitchLite Virtual sitting on same host. SwitchLite Virtual performs NAT floating IP translation and sends traffic out. Similarly, for VM1 in orange tenant. So in short, BCF P+V solution gracefully handles both east-west and north-south traffic, which in turn helps scale OpenStack deployment solution much better. BCF test path feature helps troubleshoot endpoint connectivity. All you need to do is provide source and destination endpoint information. With a click of a button, you can immediately get logical path and physical path that traffic will take when traversing between these endpoints. As shown here, we have extended this functionality to virtual switch as well. Now it's fairly easy to troubleshoot VM to VM connectivity with a click of a button. Moving to security groups. Security groups are OpenStack way to achieve microsegmentation. Here, OpenStack admin or end user configures security group on OpenStack Horizon interface. Once configured, these security groups are enforced on host. Now, let's say, due to security group, if traffic is dropped, first reaction of end user is, it's a network problem. Network admin has no visibility on these security groups. Hence, it can take fairly long time to resolve this problem. Leveraging BSN Neutron plugin, BCF controller provides security group visibility. As shown on left-hand side, allow SSH security group is configured in Horizon. Lower part of the screen shows how it will be seen on Big Cloud Fabric Controller GUI. Network admin has complete visibility of these security groups. Additionally, we have extended test path feature for security group as well. So if traffic is impacted by security group, one can very easily debug and find out the root cause of the problem. Let's look at the demo of Big Cloud Fabric P+V solution.
Welcome to the video demonstration of Big Cloud Fabric P+V Fabric Edition. I'll be demonstrating Big Cloud Fabric P+V Physical plus Virtual Edition in 3 parts. First, I'll demonstrate the auto discovery of host and the switch light virtual and showcase how BCF controller manages the switch light virtual as part of single unified P+V fabric. Secondly, I will show OpenStack tenant workflow for application deployment to show how dynamically BCF P+V fabric gets provisioned for both layer 2 and layer 3 networking as and when OpenStack tenant creates network configuration on Horizon dashboard. Finally, I'll demonstrate how BCF extends the test path and fabric analytics to switch light virtual, which enhances the visibility and troubleshooting in the BCF P+V fabric. To demonstrate that, I'll be using BCF 2-rack topology with 4 compute hosts which are part of OpenStack cluster. As part of initial deployment, the OpenStack cluster is installed with Big Cloud Fabric plugins for OpenStack Neutron with SwitchLite Virtual installed on these compute nodes. The entire physical and virtual switches are managed by Big Cloud Fabric controllers as a single P+V fabric. Let's look at how BCF controller auto detects and manages the SwitchLite Virtual. This is the BCF controller web interface. Fabric view shows the physical topology used, in this case 2-rack topology. With the Big Cloud Fabric P+V edition, the fabric view shows the hosts running SwitchLite Virtual at the bottom of the fabric page, and these are auto detected and managed by BCF controller. Mouse hovering on any of the switches shows the information about that particular switch. For example, R1-host1 and R1-host2. The LEDs on the switches shows the switch connectivity to the controller and the fabric. LEDs around the switches shows the interface status. If you want to see the switch light virtual associated with particular rack, then click on the leaf switch for that rack. For example, rack 1 shows only 2 switch light virtual. Rack 2 shows only 1 switch light virtual. Let's connect second host R2 host 2 to the second rack by bringing the link up. As you bring up the link, BCF controller auto detects that host and forms the link aggregation and starts managing the switch light virtual as part of the fabric. If you click on the new switch, on left panel, it provides additional details on the virtual NIC where VMs are connected and uplink where it is connected to physical leaf. That's how Big Cloud Fabric auto detects the host with SwitchLite Virtual and starts managing it as part of single unified BCF P+V fabric. Demo 2. Let's look at the OpenStack tenant workflow for application deployment. The Big Switch OpenStack Neutron ML2 driver and L3 plugin enables dynamic provisioning of Big Cloud Fabric for both Layer 2 and Layer 3 networking, as and when OpenStack tenant creates network and router on Horizon dashboard. BCF also handles the floating IP and the NAT as part of the auto provisioning. BCF tenant view shows the tenant blue, which is auto configured through the OpenStack plugin. Let's look at the OpenStack Horizon dashboard for blue tenant or project. This has been configured with 3-tier application, web, app, and database tier, with each of the network having 2 VMs each, and tenant blue router interconnecting them. Router interface has IP address of .1 in the given IP subnet, which are 10.100.41, 42, and 43. Now let's look at the BCF tenant detailed view. The tenant logical topology shows the 3-tier with the logical router. Logical router interface IP addresses are shown on the segment. If you look at the configuration view, it has created 3 segments to reflect 3 networks in the OpenStack Blue tenant. With logical router interface with the IP address, which will be used as a gateway by all VMs in that network or segment. And BCF uses the distributed logical router to provide routing for all the OpenStack workloads. BCF also provides the visibility into the OpenStack tenant security group configuration as shown on the screen. With that, let's create new tenant network topology, say red tenant on OpenStack, and see how it dynamically gets provisioned on Big Cloud Fabric. Let's use the OpenStack heat template, that is the other enhancements BCF plugin provides to the end tenant admin, which makes application deployment faster and simpler. Let's use 3-tier app template. Fill in the IP subnet for each of the tier as per your need. Here I am using 10.100.31, 32, and 33 with /24 mask. Apply the template. Now let's switch to BCF controller and refresh the tenant page. As you see, the new tenant red got configured on Big Cloud Fabric. There is no manual configuration needed. If you click on the tenant details, you see the logical topology for the new tenant. Also see the 3 segments and the logical router interface with the IP address. Let's add instances or VMs to this tenant. Add 3 VMs each in each of the network. First, web VMs. Choose the web network. Similarly, create 3 instances in the app network. 3 instances in DB network as well. Now all the instances are up and running. Let's switch to BCF endpoint table and filter it to show only endpoints in new red tenant. As you see, the endpoints already been learned on the BCF fabric, and table provides detailed info about the endpoints, including IP and MAC, where it is physically located in the cluster by switchlight virtual name and the virtual interface used. That's how auto provisioning of the Big Cloud Fabric unified P+V Fabric for Layer 2 and Layer 3 networking works with OpenStack. Demo 3. Big Cloud Fabric P+V edition extends test path and fabric analytics feature to provide visibility and troubleshooting to switchlight virtual. First, we'll look into test path feature. The BCF test path feature, which is visibility feature used for troubleshooting connectivity issues between the endpoints in the BCF fabric, is extended to trace path from and to virtual switch in the unified P+V deployment. Let's do a test path between 2 endpoints. Pick source endpoint in web segment, say 10.100.41.2, and destination endpoint in DB segment 10.100.43.5. Let's run a simulate mode. This provides the logical path, which helps in understanding the exact routing and policy configuration. If there is any misconfiguration, this would indicate that. Physical path view provides the exact physical path. With the P+V edition, it includes source switchlight virtual, in this case R1-host2, and also the destination switchlight virtual R1-host1, where this particular endpoint resides, and also provides the physical leaf and spine switch details. The test path test mode would give more granularity by providing ingress and egress interface details at every switch, both virtual and physical, for the given flow. As shown, the given flow takes R2 host 1 QVO interface, where it is connected, sent to uplink, which is connected to R2 L2 Ethernet 1, then it goes to spine 2, and then received on Ethernet 50 of R1 L1, and then forwarded to R1 host 1 on E2. Now let's take another example of test path. Let's trace the path from web1 host, which is having the floating IP, to the internet IP, say 8.8.8, which is a public DNS server. From logical path, you can see that the traffic is getting NATed, as traffic is meant for external to the BCF fabric, and source as floating IP assigned. From physical path, you can see that the floating IP is implemented locally on the source switchlight virtual, which does NAT on the local host, and then it is sent to external core router through the physical leaf switch. This test path feature is also extended to OpenStack Tenant. Big Switch Horizon enhancements enables the test path feature to be used by the OpenStack tenant for any connectivity issues. They can run these reachability tests using the Horizon Reachability Test tab and understand the exact physical path traffic between the VMs take. As you see, this is the app to DB test, provide segment name and IP of source and destination VMs. Similarly, other tests, run these tests, and results are shown in the status column. Click on the result for web-to-db test. You see the exactly same result on OpenStack dashboard like we saw a few minutes back on the BCF test path page for the given endpoint pair. That's how BCF test path or reachability test helps OpenStack user to debug the application connectivity issues before opening the ticket with networking team. Next, look at the BCF Fabric Analytics feature, which is extended to provide visibility into the switch light virtual along with physical switches. As you can see, the dashboard shows the graphical representation of all the physical and virtual switches and the events associated with it. You can click on the switch name on the pie chart to get the events associated with that particular switch. Bottom of the screen provides more details into the events and the time window. In summary, Big Cloud Fabric P+V edition automates the fabric provisioning for layer 2 and layer 3 networking for OpenStack workloads, which includes the floating IP and NAT. And it also extends the visibility and troubleshooting tools into the switchlight virtual. Thank you.
That was great demo. Thank you so much, Ganpati. In the interest of time, let's conclude the presentation here. There were a few questions from our attendees that we've addressed in the webinar window. If there are additional questions anyone has on OpenStack integration or how we've extended the P-Fabric notion to a unified physical plus virtual fabric, please reach out to us at info@bigswitch.com and we'd be happy to answer those questions there. As I mentioned at the start of the webinar, all of our past webinars, including this one, will be available online at bigswitch.com/webinars. Just to reiterate, if you want to try out Big Cloud Fabric P+V edition or Big Cloud Fabric OpenStack integration with our P+V Fabric, all of that is available at your fingertips at labs.bigswitch.com. So we have a couple of new modules there. You can just log in there. You don't have to install OpenStack. You don't have to worry about where OpenStack controller sits. All of that is pre-configured for you, so you can try it at labs.bigswitch.com. In a couple of weeks from now, as I mentioned at the start of the webinar, we have another exciting topic lined up. We will be joined by Red Hat, and we'll be talking about the RHOS 7 integration for Big Cloud Fabric. That's a continuation of our Tech Alliance Partner Series, and that will be the same week as OpenStack Summit. So we look forward to having you on that webinar. And this concludes our presentation for today. Thank you all, and have a great rest of the week.